Even functions of Fourier series. I have already explained you about even function and odd function in the previous lecture. That was just the common understanding of even and odd functions. Now I'm going to talk about even functions of Fourier series and odd functions of Fourier series. So first I have even function of Fourier series. What is even function of Fourier series? If a periodic function f of x is even, then a sub naught equals to 1 over 2 pi times integral of f of x dx with the limit from minus pi to plus pi, which equals to 1 over 2 pi into 2 times integral of f of x dx with the limits from 0 to pi. If the function f of x is even, then this is going to be a formula for the coefficient a sub naught. Why I put 2 here? It is just to remove the limits from minus pi to plus pi and to make it from 0 to pi. Therefore I'm going to multiply it by 2. Let me show you graphically. Here is a waveform at origin 0 and its range is from minus pi to plus pi. So the interval from minus pi to plus pi is a complete cycle, which is minus pi to plus pi. But from 0 to pi is a half cycle. So to make a complete cycle, I'm going to take a half cycle 2 times, and therefore I multiply it by 2. There is nothing very special here. It is just to make the integration simple. It's going to only help you when you solve an integration process with the limit from 0 to pi. Similarly, the formula for the a sub n equals to 1 over pi times integral of f of x times cos nx dx, which equals to 1 over pi into 2 times integral of f of x times cos nx dx. If the given function is even, cos nx is also even. Remember, I have already explained you in a prerequisite lecture that cos nx is even, sin nx is odd. So here even times even equals to even. So this whole function is even here, and I have this formula for the a sub n. Similarly here I just replaced the limits by 0 to plus pi and multiplied it by 2. But what if I take b sub n? It equals to 0. Why? Because the given function is even and sin nx is odd. So even times odd equals to odd. Now according to the rule, if you have odd function of Fourier series, it always equals to 0. So this whole function is odd function. You have only the value for the coefficients if the function is even function. If the function is odd, your coefficient value is 0. The function is even, you have the value for a sub naught and the value for a sub n. But the value for b sub n equals to 0. So I don't need b sub n. For the even function of Fourier series, I have only a sub naught and a sub n. My b sub n gonna be 0. I don't have b sub n if the function is even function in Fourier series. Odd function of Fourier series. If the periodic function f of x is odd, then a sub naught equals to 0. I have already mentioned you that if the function is odd, according to the rule of Fourier series, the coefficient value will be 0. So here a sub naught equals to 0. But when you take b sub n, it equals to 1 over pi into 2 times integral of f of x times sin nx dx. Because the given function is odd function and sin nx is also odd function. So odd function times odd function equals to even function. So this whole thing is even. Therefore I have the value for b sub n. I just replaced these limits by 0 and pi and multiplied it by 2. But what if I take a sub n? It equals to 0. How? The given function is odd. Cos nx is even. So odd times even equals to odd. Remember, I have already mentioned the odd and even function in a prerequisite lecture. So this whole thing is odd. And according to the Fourier series, if the function is odd, it equals to 0. So if I have odd function of Fourier series, my a sub naught is 0. I have only b sub n, and my a sub n is also 0. So I have nothing to do with the a sub naught and a sub n. I have only b sub n if the function is odd in Fourier series.